Then coming to the next topic, that is Townsend's breakdown mechanism. So Townsend's breakdown mechanism. So because of delicate material lost its property, the Townsend's breakdown mechanism explain the when the delicate breakdown occur, when the delicate material lost its property can be explained by using Townsend's breakdown mechanism. Okay. That means when the dielectric material lost its property, means it lost its dielectric property. That means it's acting as conductor instead of insulator. The dielectric material acting as conductor instead of insulator. So that's why we must know the property of insulator. So this condition can be explained insulating property. So where this breakdown occur? Okay, so when the voltage between the anode and cathode increased, that means whatever the current supplied from the source, current is equal to the current flowing through the dielectric material. That means the dielectric material acting as a conductor instead of acting as an insulator. So that the current is maximum. So ideally it's infinity current, but in practically, so we are considering that is called current maximum circuit, maximum current, that is called external current, whatever the supply. Whatever the current supplied by the source, that current is equal to the current flowing through the dielectric material. Then here equation A is equal to I naught into e power alpha d by 1 is gamma into e power alpha d minus 1. Substitute here current is equal to infinity 1 by 0. Then we will get here 1 minus gamma into e power alpha d minus 1 is equal to 0. Then so we are getting e power alpha gamma into e power alpha d is equal to 1. So here all e power alpha d is greater than 1. So this e power alpha d is called avalanche. Okay, so growth of rates of current. Okay, that is called avalanche. Here, d power alpha d is very high. That means it's maybe 10 to the power of 6 to 10 to the power of 8. Okay, so practically it is a 10 to the power of 6 to 10 to the power of 8. That's why compared to 1, this 10 to the power of 6 is very high. That's why we are neglecting 1 here. Okay, so we are neglecting 1. The equation will become like this: gamma into e power alpha d is equal to 1. Gamma, this is not b, yet gamma into e power alpha d is equal to 1. The current in anode is equal to the current in external circuit. Under breakdown condition, whatever the current supplied by the source, that current is equal to the current flowing through the dielectric material. Okay, theoretically the current becomes infinity. So practically it will be some limited because of resistance. Okay. Theoretically, the current becomes infinitely large under the above mentioned conditions, but practically it is limited to by the resistance of the external circuit. So we are using external current limiting resistor. So by using that, we are limited the current. The condition gamma into power alpha d is equal to 1 defines the condition for beginning of spark and is known as Townsend's criterion for breakdown. So gamma into e power alpha d is equal to 1. That condition, we can say that the spark is appearing in gas. Okay. So based on this condition, we can say that the property of the dielectric material, when the spark is occurring in dielectric material. Okay. So based on these conditions, gamma into e power alpha d is equal to 1, or gamma into e power alpha d is less than 1, or gamma into e power alpha d is greater than 1. Based on that conditions, we can say that Townsend's criterion for maximum breakdown. Okay. So yeah, so there are the different conditions are there. Gamma into e power alpha d is equal to 1, and gamma into e power alpha d is greater than 1, and gamma into e power alpha d is less than 1. These are the 3 different type of conditions can be explained by using Townsend's breakdown criterion. When gamma into e power alpha d is equal to 1, it's called a self-sustained region. Okay, at which the spark is appearing here, gamma into e power alpha d is equal to, at which position, at this condition, this spark is ready to take place in the gas. Okay, gamma into power alpha is one called threshold sparking condition. Okay, so and the gamma into power alpha is greater than 1 is called self-sustained, is also self-sustained region, but the gamma into power alpha is greater than 1 condition. So the spark is appear rapidly. Okay, this spark discharge grows more rapidly. The more gamma into power alpha d exceeds the unity. That means gamma into power alpha d is greater than 1 if it's a condition. The spark is appear across the gas again and again. Okay, and then next gamma t power alpha is less than 1 scalar, not self-sustained region. That means the availability of free electrons in the gas is very less. Gamma t power alpha is less than 1 condition. The availability of free electrons are less. That's why the spark is not appear in this region. Gamma t power alpha is less than 1. At gamma t power alpha is greater than 1 and gamma t power alpha is equal to 1. The two conditions only the spark is appear across the gas. These three conditions, okay, by we can explain by using graph. I mean, current to growth curve of Townsend's discharge. Okay, in this there are three different type of regions we can classify into this curve. Current to growth curve by Townsend's discharge can be explained by three regions. That is called first one ohmic region, and saturation region, and Townsend's discharge region. First one ohmic region, second saturation region, and next third Townsend's discharge region. So here discharge first ohmic region 0 to A. So here slowly current is increasing. Okay, this slowly current is increasing. The insulator, it will be current across the insulator. The current is slowly increasing. It satisfies when it just allows the Ohm's law. Okay, we know that Ohm's law V is proportional to I. So according to the voltage grows slowly increasing. According to that voltage, the current is slowly increasing. That's why this region is called ohmic region. After that ohmic region, the current in the gas is sometimes is constant, even the voltage increasing. Even the voltage increasing, the current is constant. That region is called saturation region. And above that saturation region, current is increasing because of the availability of free electrons are more in this gap between two electrons. Okay, the availability of free electrons goes on increasing. That's why the current goes on increasing. So like this, so up to here of the C region, the 0 to C region, there is no spark across the gas, but behind the C region, behind this point C, the spark appear across the gas material. So that's why this region 0 to C region, this region is called non-sustained region. After the C region is called self-sustained region. After the C and can call it self-sustained region. So yeah, based on C, we can say that the dielectric material property, that is when maximum breakdown. So gamma in T power alpha D is equal to 1. Okay, gamma in T power alpha D is equal to 1. This point is called region near the point C, indicates the threshold region. Gamma in T power alpha D is 1. So here, this spark is up here, ready to take place here. So okay, that's why this point C is called gamma in T power alpha D is equal to 1. Okay, unless gamma in T power alpha D is greater than 1, means behind the C, this position is called gamma in T power alpha D is greater than 1. Okay, so behind the C position point, this gamma in T power alpha D is greater than 1. Here, the spark is appear between two electrodes, that is called across the gas. Again and again, more rapidly, the spark is appear across the electrode in a gas. That's why this region is called self-sustained discharge region. Behind the C region, this spark is appear in this electrodes again and again. Okay, that means here there is no spark is appear across the transmission. 0 to C region is called gamma in T power alpha D is less than 1. Okay, so because of availability of free electrons are less in this region 0 to C, that's why there is no spark is appear across this. So at which gamma, if it's at point C, gamma in T power alpha D is equal to 1. At which point the spark is ready to take place, and behind C, this spark is appear in the transmission line across the dielectric material, that is called gas. So then next concept, limitations of Townsend's theory. Limitations of Townsend's theory. So this Townsend's theory, this alpha is called the primary ionization coefficient, is proportional to the E by P ratio. So E is called electric field, P is called pressure here. So why is taken like this? There is no proper proof for this explanation. So why is taken alpha is proportional to the E by P? There is no proper proof. Okay, so he's taken some assumption alpha is proportional to E by P, and this Townsend's theory is applicable for only uniform electric fields. So it's not valid for non-uniform electric fields. And it's taken a lot of assumptions uh, by deriving the equations and by explaining this in Townsend's theory is explaining some concept by taking assumptions. Okay, so the assumptions are also there is no proper proof. Okay, so and then it's the dielectric breakdown. Okay, it's depending on so the dielectric breakdown depending on shape of electrons, nature of electrons, temperature, humidity. So it's not taken this type of conditions in the shape of the is not taken is not explained shape of the electrodes and also nature of the electrodes. And also is not taken by while explaining this concept temperature also humidity also. Okay, without considering these considerations is derived expression and is explain this concept. Okay, this is the concept drawback. This is some limitations of Townsend theory, and also here Townsend and also so many one more here four disadvantages is there. So limitations are there. One more another limitations also there. See here Townsend's theory mechanism applied to gas discharge phenomena was found some taking some drawbacks or some limitations are there. First drawback is that according to Townsend's theory, current growth across a result of ionization process only, but in practice, breakdown voltage were found to be dependent on the gas pressure and the geometry of the gap. Okay, so that is not taken geometry of the gap and also is not taken electrode um, shape of electrodes, nature of electrodes. Okay, so that is the first drawback. The second one, Townsend's mechanism predicts the time lag of 10 to the power of minus 5 seconds. While practice, the breakdown was observed to occur very short time in the order of 10 to the power of minus 8 seconds. Okay. Actually, this practically the 10 to the power of minus 8 seconds. It is very less time to take this spark is up here in across the gas. But it's taken assumption is predicted uh, time lag 10 to the power of minus 5 seconds. So that is the limitations of the Townsend's theory. And then Townsend's mechanism predicted the very diffusal from of discharge, but in practice it was found that to be filament and irregular. That is non-uniform electric field. Okay, so it's not valid for non-uniform electric field. So this is about limitations of Townsend's theory and uh, current and maximum breakdown condition. Okay.